So we successfully did the shooting, and you saw how it can be fun and interesting to take different objects and different situations using a camera to scan and to make photogrammetry with objects. Now, since we have created these objects in our camera, we need to transfer the images from the camera to the computer. So in this case, I recommend you to be careful, because many people take the pictures with the smartphone and then send them to themselves using a messenger. But please be aware, there are two things when you use a messenger that can happen if you use the wrong settings. First of all, the images are highly compressed. This is because the messenger wants to reduce the data and send the objects very quickly. So be careful that you transfer the images not as images but as files. So they are what they are, a JPEG file or a PNG file, depending what you actually shot. And what can also be sometimes difficult is that the messenger, for privacy reasons, removes all the information that is inside the image. So the time it was taken, the location, or even the most important information for our purpose, which focal lengths, the exposure time, and all what is usually in the description of an image. So we would like to use all this kind of data for making our photogrammetric 3D model reconstruction. So when you transfer the images to your computer, please be careful. There are systems like copying directly with a tethered USB cable, or you can then send them to you over the network using Wi-Fi. So please do this, because I saw many students who destroyed the good quality of their work by using the wrong method of image and file transfer. So I hope this will not happen to you. So once we have these images, you will probably have them in a folder, and we can have a look what this looks like. In our case here, I put the different scans that we had here in a folder, and for example, if we take the doll image, you would see that we have all the different pictures that we took together. I'm showing you here this a little bit larger, if this is possible. So the program allows to show these images in a different style. We can also watch this as a gallery as we go by and see the different images. So this is a way, and all the important meta information, like I told you, that gets removed when you are using a messenger, is what you find in the information of the file here on the right side. So when this was created, the resolution and how this was made, the focal length and the speed. So these are important information. The software is also reading in order to find the good optical parameters for calculating the images. So this is what I would like to show you. There is a way, depending on what you took with the camera, how you convert the images. In this case here, because it is an Apple, it is a HAIC format, but I converted the images also to JPEG, so you will see that the JPEG images are also here showing the same image, and this is easier to use later for the program. So I've prepared the images, and I would like to have a look at you now regarding the next step, which is the software. and we will talk about the software for 3D remodeling. And there are many tools available on the market, and what I would like to show you in this lessons are two tools which I think are very important, and I had quite a good experience with them to do research and to experiment, so this is what I recommend you also to use. And the very big advantage is that these tools are free to use on most of the computers. The Visual SFM structure from motion is an application which is aiming at Windows applications and Linux. It's a bit older, and we have the new implementation of the Apple ARKit, which I also would like to show you, since this is a very modern approach for creating elements for the metaverse. Visual SFM is a more older tool, and this has been around for a long time. This tool is very good for showing the process that is actually happening in the whole pipeline of the reconstruction. You will see that we have different steps. Some of them I explained to you already, and others I'm going to show you right in a moment. So let's start by jumping to the first example I would like to show you, and that is the software Visual SFM. And the tool Visual SFM is available on the internet for download, and I recommend you have a look at the page. If you follow the link I'm sending here, you will get on this page by Chang Wu, and this describes a visual structure from motion system. And system, it is actually a system because it involves in fact many different steps. So what are the different steps? The different steps are, first, this Visual SFM is a tool for giving you a user interface. You will see the next tool from Apple is using the command line, but for people who like to work with the mouse and click buttons to work on a process, the Visual SFM user interface is quite useful, and I will explain to you how this works and how you can use it. The visual user interface is a surface for interacting with different tools, and there are a couple of tools which I explain to you right now. So you will see here on the top that there are different versions available for download. So this is the Windows and Linux and Mac OS versions, which are available here. So if you look at this, this is the user interface. This works in an accelerated mode if you have a CUDA capable graphic card. However, CUDA is limited to NVIDIA graphic cards, and there are also new standards for OpenCL computing languages or Metal, other things that different platforms used. So not all the computers have CUDA, not all the computers have NVIDIA compatible graphic card. So this is why you have two versions for Windows. And the tool is managing the whole process of creating a 3D model. However, it needs a couple of other tools, and if you look here at the other installation instructions here on the top, it says that you need additional tools like the SIFT algorithm, which is patented in some countries for a certain purpose, are not always available for free, but there are some versions or some similar versions that use this to implement the recognition and registration of feature points using the GPU, which is a very big advantage. And then there are a couple of other tools that are linked on the page, which I recommend for you to look at, and you will find this here on the top of the page with all the links, and these are the links where you can find the tools that are necessary for matching the feature points. So we will you will see that you have to install a couple of these tools to get the whole process of Visual SFM to work. And since these tools have been developed by different people for 32, for 64 bits, and they are on different platforms already for a long time, it takes a couple of experimental steps to get this to work. But once this works, and I will show you, this is actually quite satisfying. And I will explain to you the interface just in a moment. So this is where you get the Visual SFM, and in the next step, the overview of the Visual SM user interface shows actually your workflow from left to right, or here from right to left, because I'm opposite on the screen. So the first step is to open your images. The second step is to detect the features. This is what you see in step number 2, match the images. You then have the step number 3, which is the reconstruction using the points that are matching on multiple images, what I explained to you before, the identical point. And the last step of what you can do is to increase the number of points and to make this a very, very dense point cloud model. And this dense point cloud model is then something you can turn into a mesh object with a texture to work on it in a 3D program or any game engine that creates virtual reality and metaverse objects, which I want to show you in this class. So let's have a first look and see how we can actually generate this point cloud. I would like to show you now how we use Visual SFM, and for this we will have a look at the program. And what you see here on the top is the process of working with the images, the whole workflow, the pipeline of what we actually have here. And you see that we have all these buttons, so we're going to add new images, we're going to create the matches, and in the next step we are going to create the point cloud. To show you how this works and what is actually happening, I'm going to do this with new. So in the first part, I'm going to open multiple images, and you can see this dialog here, the multiple images. If you go and file, open multiple images, you will have the dialog appearing, and then you can choose the images that you like. So in this case here, I'm going to choose all the images from begin to the end, and we have these JPEGs here now all selected, and I click open, which is going to take a little bit of time. I'm doing this in real time now with you. So the image is going to be analyzed, and we see here the log on the right side is showing how much time it took and what the size and focal length of these images. So this is important for reading the image with the metadata. So we can see all our images here in the view options. You have different alternatives of what we can change, but let's leave it like this. And in the next step, we're going to compute the missing matches, and this is going to create all the SIFT feature point detectors for every image. And if I hit this button, you would see now on the right side that the SIFT here is being calculated. So depending if you have a GPU or if you have a strong computer, this will go more or less faster. We have 69 images, and I'm doing this in real time for you now. So you see that we had these images here, and what is happening now, the program is checking if there are matches between the images. So this takes a certain time, and you will see that every image is going to be matched with the other images. And since this is going to take a lot of time, I'm going to accelerate the time a little bit and come back to you when we are at the end of this process. So let's make a little break and continue when this whole process, which lasts for me of almost half an hour. So if you try it, check what is going on in the log file, and it will be longer the more images you have. So here with 64 images, you would see this process finished after the acceleration of this break time. What you see here in the background now is the last part of the matching of feature points in the different steps, and you see that the whole software here is trying to compare each image one with the other. We have in total 69 images, and we just saw that the image matched in 2492 seconds. So the higher your resolution, also the higher is your the time you need for this pairwise matching, and of course the number of images increase. So this is something where you should be careful in the beginning. Don't maybe start with too many images in the beginning. What I show you here is 69 images I have made of this object. And when we go now back to the software and we leave the log window behind, you see that we have here in the next step of our user interface, after computing the matches, that we have the 3D reconstruction, and we're going to do this now and see in real time how this is going to work. So I'm going to put the window here, and we will now see what happens if we start with the 3D reconstruction. And you see actually that in front of our eyes the whole scene shows where all the different cameras are, and the more cameras there are, the more you can also see how our little statue is appearing. And this will take some time, but you see that we have all the different positions here, and from all the different point of view we saw how the point cloud is generated here with all these multiple point of views. So this gives an overview how the more points you have and the more perspective we create, every perspective is adding more and more points. You see this now in real time. So we have the full reconstruction of first point cloud, and you see here that all our cameras are here. Now there is one point I would like to show you as well, is you have here this 3+. This shows actually only the points that are seen by 3 cameras. If we turn this off, we have even more cameras. So this is a sort of accuracy error in showing how this works. So if I move this around, you can actually see how the whole object is moving in different sizes. So this is what I wanted to show you here in this example. And if you want to visualize the whole scene a bit differently, you can do this, of course. In the view menu here, you have the possibility to remove the dark background. So if we remove the dark background, this becomes white. So this is maybe a little bit easier to see how this is working and interacting. You can use the mouse wheel to zoom in or out the little scene, and this shows our little guy here. So you would say this is not really very convincing. We could do this a bit better, and in fact in the next step, once we have the model, we have to do a dense point cloud. So the dense point cloud is the next step here, and this is actually here what you find in this menu here, where you can reconstruct the dense images, or you have this here. However, I'm not going to show you this now because this takes too long using this structure from motion tool. What I wanted to show you here is the procedure and what the tool is actually doing, because this is working in real time. So the result of what we did here is to create a point cloud, and with Visual SFM we create first a rough point cloud by matching all these points, and after that we can reconstruct these points, and in the next step you create a dense point cloud. So if you have a lot of time, you can start this process as well, and then you will get a model that is very dense and has more detailed in the structure. So this is what I would like to show you about the Software Visual SFM. This is a tool you can download and you can practice for yourself. We will make a little break now, and then we will talk about the next software tool and the last part of this lesson, which is the Apple AR. So take a little break and we will continue in a second. We finished with the previous example and created a point cloud using Visual SFM. What I'm going to show you now is part of the latest operating system of Apple, and this is because Apple has been introducing a lot of tools which are inside the system. So if you have an Apple computer, you don't need actually a lot of other software. And what I would like to show you now is the similar process which can be used when we use Apple AR Kit. And in this case, we are not going to end only with a point cloud, but we are going to have a 3D model with texture at the end. So how does this actually work? In the operating system, there is a part of the software that can do everything that we have discussed and shown in the Visual SFM, but it goes a step further. It also creates what is called a universal scene description. So this is a 3D model containing texture and normal maps. So everything that makes a 3D object like this little one ready to go into virtual reality. And since this is actually really very impressive and was also a very interesting discovery for me, I would like to show you how this works. So when we had before the tool Visual SFM, you will understand why the user interface was so important for certain people to do the photogrammetry. The tool we are going to use now is inside the operating system, so many applications you can buy use this library of the system, but if you want to access these functions, you have to somehow to get a connection, and this can be done to the computer by using the user interface of the command line. So this is a command line tool for creating a 3D object, and in the background it is using the Apple AR Kit, and we are going to do this now in real time, the same process what we did using Visual SFM. and I'm going to switch to my screen and open the terminal. So I hope you can see everything here. I try to make it a little bit larger on the right side. So here we have the tools, and as you see here, I'm on my desktop, and on the desktop here I have a folder with images. So in my images, if I change to images, cd change directory, and in the images I have the doll number 2, the rows, all different kind of images that we scanned before together. And what I would like to do now is I would like to use the photogrammetry tool to use this doll number 2 and to turn this into universal scene description object. And this is what we're going to do. So you will see that I have the images here of doll number 2. They are here, so the whole folder contains these pictures and the one that I have shown to you before. And we're going to use the command now, hello photogrammetry. And hello photogrammetry has a built-in manual. So if you type, I'm on the American keyboard, so I have to change to my German keyboard here. So if we type -H for help, you will see that we have here the description of the tool. So the first one is we have to give the command. The second is that we want to have the input folder with the images, and the second one is the full path to this USCD output file. So we have to tell the program where the result should be saved, and there are a couple of options, and these options are described here. So first is the level of detail. How big do you want to this object to be at the end? Do you want to use this in a video game? Are you going to make a movie? Is it enough if it is just shown in AR application using the smartphone? So you have different detail level. You have preview, reduced, medium, full, and raw. So this is basically the quality of the texture that you can determine here. And you have an order, so this can accelerate or simplify the stuff if you know that all these images were taken in a pattern or if they are random. So I'm not going to use this one. You also have an additional point if there is very little structure. So if it is very smooth, everything is black, or there is a surfer with very little structure, you can increase the sensitivity. So both of this is not necessary, and we're going to do this now. I clear the screen and I'm going to type hello hello photogrammetry, and then in this case here I can give as an input folder doll2, and the output folder I will give this on the top image level. I will go into models and I will create a name. I will call this doll2, and then very simple USD Z. So this is my file name, and we're going to add the detail preview. So this is the detail preview, and this is the whole command. So if we start the whole process now, the computer is going to compute. You see there is this cursor on the top here, and while we are doing this, the computer is working in the background, and I'm going to wait. At the same time, we're going to see how long this takes for this cursor here to move down. If you see a result, we will see what happens. But I would like to resume what is actually happening here. We are taking these 69 images in a very high and good resolution. These 69 images are then analyzed using the scale invariant feature transformation algorithm to find points of interest, and these points of interest are then registered. They have a speciality about the surrounding pixels. It shows what kind of vector is used, and that can make this point so special. And you see this software now has is still working here, but it has finished now. So while I was talking, the program was doing a step, and if we go back to the previous directory and go to the model directory, we will see that we have a new file here, USDC. So in this case, I'm going to open the model folder, and now you can see that we have this object that has been scanned by the software, which is just in front of us, and the result here is this little guy that you can see. So this is this statue which we have taken with 69 images using the Apple AR-Kit to not only create a point cloud, but this actually is a real object that we can put in the metaverse. So you have the structure, you have the texture, you have the 3D model, and this is the way how photogrammetry can actually be used very efficiently to create objects and to bring them into the virtual reality and the metaverse. So this was the lesson of today. I hope this was interesting for you. We talked about a lot of things in this program, and I hope you liked it and you can test it for yourself. Please be curious. You will find a lot of things about this on the internet, and to me this was a very interesting and fantastic lesson. I'm very happy we could do these two different methods of photogrammetry together, and eventually I hope you can also use this for some tools. So we will do more and more advanced techniques in the next lesson, and for this one I would like to thank you very much for watching everything about photogrammetry. I'm saying goodbye for today, and I hope to see you very soon in one of the next videos.